what's going on, guys? It's your Poynting video again with another tutorial of physics, and I'm very excited to announce this explanation of this problem. You can do it in a way to use the unit of each. So we have y, the quantity of the speed of light multiplied by the magnetic field is equal to electric field. That's mean this is the formula I'm gonna show you right now. So there is two part of this. There's the electric field. Electric field, we know that electric field is equal to force divided by the charge. And we know that the force is equal to charge multiplied by the speed multiplied by the magnetic field. Okay? So if you come on this side here, you can use the y is the electric field is the same units as the speed of light multiplied by the magnetic field. So going back here, isolate the magnetic field is going to be equal to force divided by the charge divided by the speed. So if you see at this part, electric field is equal to force divided by the charge equal the speed of light multiplied by the magnetic field, and then electric field is equal to force divided by the charge equal the speed of light. The magnetic field is equal to force divided by the charge multiplied by the speed, or the speed of light. So these two will cancel out, and electric field will be equal to force divided by the charge is equal to force divided by the charge. Okay. So what is the force? Force is equal to mass multiplied by acceleration. And what is the charge is in Coulomb. So mass, electric field is equal mass multiplied by acceleration divided by charge is equal to, actually this one is equal to, the unit of the charge is Coulomb. And in the electric field, the mass is in kilogram, and acceleration is in volt per second square, and not volt, speed, actually per second square, divided by the Coulomb. Okay, I'm just gonna do it the hard way. And this one, we do it this way. So mass multiplied by acceleration, and that's a v divided by second square, the speed multiplied by c equal, this is Coulomb, this is the speed of light multiplied by Tesla, by the magnetic field. So kilogram divided by Coulomb multiplied by speed divided by second square is equal to the speed. Tesla is kilogram divided by second Coulomb. Okay, so here the both kilogram will cancel out, Coulomb will cancel out, the second will cancel out. So what we have here, volt per second is equal the speed of light. welcome back with another tutorial of these physics problems. So I'm just gonna finish question number B. Number A, I already answered the question. Question number B, actually this both question has to do with the units. Make sure that you guys know your units, and the Poynting vector, it has to do with, I will give you the formula. What is a Poynting vector? Is that the energy that being transferred while the electromagnetic wave has been moving. So the formula is 1 divided by the constant multiplied by the electric field multiplied by the magnetic field. And to come to this to prove that the units of the Poynting vector is what divided by meter square. That mean the Poynting vector is that the watt is, it has to do with power. That's mean joule divided by second divided by the area, and that's meter square. So how to prove that this one is joule divided by second divided by meter square? First thing first, what do we have in this formula here? We have electric field and magnetic field. So what is the unit of electric field? Electric field is Newton, well actually is force divided by the charge, and that's Newton divided by Coulomb. And the magnetic field is Tesla, that's mean Newton divided by amp multiplied by meter. Okay? And the unit of the constant is the Weber divided by the amp multiplied by the meter. It is equal to Newton. What is the Weber is as Newton per meter, and divided by the area multiplied by the divided by amp by multiplied by meter, and that's the Weber. So at the end, the constant of the unit of the constant is Newton divided by amp square. Okay? So we have everything right now. So if we come back to our Poynting vector is equal to 1 over the constant multiplied by the electric field multiplied by the magnetic field. So the Poynting vector is equal, what is the constant? The constant is 1 over Newton divided by amp square. Okay? What is the unit of electric field? And that's Newton divided by Coulomb. And what is the unit of magnetic field? And that's Newton divided by amp. Newton divided by amp multiplied by meter. So here, the Poynting vector, when this one is going to be equal to the area square, when it's just going to switch it up because it's 2 division divided by, so denominator is divided by Newton multiplied by the Newton Coulomb multiplied by the Newton divided by amp multiplied by meter. Okay, so now we can start to figure out what's going on, and then we can cancel out some of the units. So Newton and Newton cancel out, the amp and the power. So what do we have left here? So we have the amp multiply by 1 over Coulomb multiply by a Newton meter. Okay, so now we can write it down like this, and this one is amp Newton divided by Coulomb meter. Newton so now the amp, if we can start to here we go, another unit that we can take out is that the current is equal to charge divided by differential of time. And if you write it down like this, this means the vector is equal to charge divided by differential of time divided by Coulomb multiplied by Newton divided by meter. The charge here is by Coulomb, so both of these will cancel out. What we have here, we have the Poynting vector is equal to Newton divided by time multiplied by meter. And if we take the Poynting vector average, Newton, we can multiply this one by both sides by meter. So the Poynting vector will be equal to Newton meter divided by second meter square. So we are almost to this to prove it's watt per meter square. So what do we have left here? Newton per meter, that's joule divided by second multiplied by meter square, and then we can write down that it's power divided by meter square.